Hey guys, Mr. McKinney here, just picking up for day 2 of our live teach for Unit 10. We're sticking with the same prompt that we had before, but I had to create an added part. This was not actually on the AP exam. There's not a whole lot of washer method that I've been able to find on the AP exam, but washer method is one of the easier ones to visualize. Sorry, this is disk method, not washer method. All right, so the region S, which is not shown, is bounded by the x-axis, the y-axis, and the function g of x in the first quadrant. So from our earlier video, we figured out that g of x is this function that's on the top, and then we're bounding it by the y-axis and the x-axis in the first quadrant. So we're looking at this region here. That's my region S. I'm asked to set up but not solve an equation that could be used to find the volume of the solid created if the region S is rotated around the y-axis. The thing that makes this the most challenging is that we're rotating around the y-axis. So this needs to be, sorry about that again. All right, so we're trying to take this region, rotate it around the y-axis. Since we're going around the y-axis, this is going to be a dy problem. Since it's a dy or a sideways problem, as Mr. Janssens refers to it, that means that we're going to need to get our functions in terms of y. So I need to get g of x. Right now it's in terms of x. So I need to solve that function to get it in terms of y, since I want to rotate it around the y-axis. When you go around a vertical axis, you have to switch everything in terms of y. Now, luckily, we're going around one of the axes. So we're going around the y-axis, which is the line x equals 0. So that's already solved for x. So now I just need to solve this equation for x. We don't need to worry about f of x at all for this problem. It doesn't come into play in this problem. Now, keep in mind, since we're going dy, we don't care about this 2. We're going from y equals 0 to y equals 4. Now, when you're trying to find the volume of a solid, if the solid touches the axis of rotation everywhere, then you're going to be using the disk method. And basically what we're going to be doing is taking horizontal lines and turning them into circles by spinning them around the y-axis. So we're going to have a circle at every layer, and when we add up all those circles, we're going to get the volume that we've created by rotating S around the axis. So when you use the disk method, the formula for volume is the integral from A to B. A lot of times you'll see the pi out front already. I like to put the pi on the inside because I think it's easier to visualize what's going on. We're doing pi times the radius squared. Now again, this is for a sideways method. I think in the notes we actually had C and D. Doesn't really matter, they just have to be limits. In this case, C and D would be 0 and 4. Now again, there's a version for the sideways method, which is this one in terms of y, and then everything's the same just in terms of x if you're going along the x-axis. All right, so the radius, keep in mind that the radius is always going to be the function. So in this case, the radius is equal to the function, which I don't have in terms of y yet, minus the axis of rotation. So it's always going to be the function minus the axis of rotation. Now the axis of rotation here is x equals 0. So we're going to be doing minus 0 when we calculate our r of y. But we should put that minus 0 into the problem to show that we have accounted for it or thought about the fact that the axis of rotation is 0. And I'll show you what I'm talking about here in a second. So the main thing that I need to do is switch this equation. Right now it's y equals 4 cosine of pi over 4x. And I need to get it in terms of x because we're doing a dy problem. So I need my radius to be in terms of y. So I'll divide by 4. Y over 4 equals cosine of pi over 4x. And then to get rid of cosine, we're going to use the inverse cosine or arc cosine. So cosine inverse of y divided by 4 is equal to pi over 4 times x. And then to get x by itself, I just need to multiply both sides by the reciprocal. So we're going to get x is 4 over pi cosine inverse of y divided by 4. So this is the same line as g of x, like x equals 4 over pi cosine inverse of y divided by 4. For every value of x and y, it'll be the same as this graph. We've just put the function in terms of y. So this is my function. So 4 over pi cosine inverse of y divided by 4. So that's going to be my radius. This function minus 0. So when I set it up, now we can go ahead and take the pi out front. We could have had it out front in the beginning, but I like to think about pi r squared, so we know that we're doing a bunch of circles. That's why we have the pi in the first place. Again, my limits should be y values, so I'm going from 0 to 4. My radius, and again, I'm going to need to square it. So my radius is the function minus the axis of rotation. So 4 over pi cosine inverse of y divided by 4 minus 0. And you do want to make sure you put the minus 0 in there because you need to show that you've thought about the axis of rotation. Now, I did not have to solve this one, and this would be on the calculator portion in all likelihood. It's unlikely that you would have to try to integrate cosine inverse. We actually haven't even taught you how to do that. So this would definitely be on the calculator version if you saw this problem. So I would stop here, put a box around it because it told me that I did not need to solve it. If I was on the calculator, I'd do math 9, and then these y's would turn into x's when I plug it into the calculator, but the value will be the same. So again, for the disk method, we're adding up a bunch of circles. So at each step, we're adding up pi r squared. In this example, I did the sideways method because we were rotating around the y-axis, which is a vertical line. So if you rotate around a vertical line, then you're going to be integrating along a y-axis, or you're going to integrate with respect to y. So that was the more challenging part of this one, was switching it in terms of y. So anytime you're rotating around a y-axis, you need to put the equations in terms of y. Sometimes they'll give you equations in terms of y, and sometimes you'll have to do what I did here and solve for y. So again, this was the live teach for day 2. It was just a little added portion to go through the disk method, and this was the sideways version of the disk method. The not sideways or the straightforward version is in the other videos that I've recorded. Hope this was helpful. Have a great day.